In one of my past videos, I talked about how to economize energy by using just a single water heater to serve an apartment. Because I used to laugh at some people when they build their house, in all the bedroom, like 5 or 6 bedroom in a single apartment, they install water heater in each of the bedroom. At the end of the day, most water heater might be left for years without being operated simply because of the cost of energy. So instead of wasting our money, we can actually make use of one water heater, a single water heater to serve the whole apartment. How do we do that? I said it in one of my past videos where I talked about using 3-way switches. But someone further asked that, is it possible for us to control it from 3 different positions? And I said yes. So that is why I come up with this video, that we can use our normal single lighting switches, 6 amps lighting switches, to control our water heater, and in 3 different positions. For example, if the building is a 3-bedroom apartment or 2-bedroom apartment, but there is a need for water heater probably in the kitchen, making it 3 different positions where we can operate the water heater. Our water heater can be bought and centralized in a position that can make it possible to serve the 3 rooms or the 3 locations where we need to dispense hot water. So in that case, we can decide to look for an appropriate place to position our water heater. Then we position switches in the 3 rooms or in the 3 positions where we can easily switch it on and off. So how do we go about that? As an electrician, you must know all this very well. In case this video is too long, you may not be able to watch it completely on Facebook. You can go to my YouTube channel for the complete clip. To do this, we need the following items, the following materials. We are going to get our 1-gang 2-way switches, 2 number. Then we need intermediate switch, just 1. So making it the 3, just 1. 1 is okay. Let me change this to 1. 1 is okay. So 1. So in total, we need 3 switches. 1-gang 2 ways, 2 pieces, then intermediate switch, just a piece of it. Then we need our magnetic contactor. The reason why we need magnetic contactor is that magnetic contactor is the device that we are going to use to drive the water heater for switching in those 3 different positions. So what the magnetic contactor is the one carrying the load, and the coil of the magnetic contactor is the one that will be controlled by those switches, not the water heater. You know, the rating of the water heater is 20 amps and above. So, and you cannot use a lighting switch, which is 6 ampere, to control a 20 amps rated load. So in that case, we are going to shift the burden of the load to the magnetic contactor, while we use our lighting switches to control the coil of the magnetic contactor. So magnetic contactor, we need just 1. And our water heater, just water heater tank is okay for that building. So after having all this, let us now see how the connection can be done. So let's see it. So let us see the wiring diagram of the connection of a water heater controlled water. This is our distribution board. From our distribution board, we are going to take the supply. Don't forget, this our supply cable for the water heater is going to be 4 mm, minimum of 2.5 mm, and a maximum of 4 mm, depending on the rating of the water heater anyway. But it's good to use 4 mm. So our 4 mm square cable, the live and the neutral and the earth, the 3 of them will not go directly to the water heater. It will not go directly to the water heater. Rather, we shall take it from the distribution board and connect it to the power terminal of our magnetic contactors. This is a 3-pole magnetic contactor. And out of the 3 poles, we are making use of 2, since we are dealing with single-phase supply now. So we drop the live here and the neutral here. So our magnetic contactors are 6 terminals for the power, 3 for input and 3 for output. When you hold your magnetic contactor, at the top, you see where they write 1, 3, 5. That is for the input. And you can see 1, 3, 5, they are odd numbers. So odd numbers are usually the input for the magnetic contactor in the power terminals. While the even numbers, where they write 2, 4, 6, they are the output terminals for the magnetic contactor. So the input now, we can pick 1 and 5 and leave terminal 3 unused because we are dealing with the single phase supply. So at the output side, we pick the life from 2. You can see 1 and 2. They are going to close together. So we pick from 2 to feed the water heater. Then also pick neutral from 6 to feed the water heater, which means the supply that is coming to feed your water heater. Do not forget, water heater is going to take its separate final subcircuit from the distribution board. It is a wrong practice for you to share a final subcircuit of a water heater with another water heater or with another final subcircuit. Water heater, cooker control unit, AC, each of these load takes their supply directly from the distribution board, and they should not share the circuits with another final subcircuit. So that is it. Even they must not share neutral. The neutral for a final subcircuit must go directly to that final subcircuit. Should not share the neutral. So that is it. So we pick it from a breaker, MCB, from the distribution board to this place, then from the neutral bar to this place. This is our distribution board. So from the output, we feed it to our water heater tank. But if you look at this magnetic contactor here, the upper terminals and the lower terminals, you can see they are not closed. They are open. And that is the way our magnetic contactor is designed. So if you look at this place, there is a coil here. This coil here, that is the energizing coil of the magnetic contactor. The coil here is wound over a soft iron core. So once you pick the life and neutral and feed it to A1 and A2 here, which are the terminals of this coil, the soft iron core here becomes a magnet. And once it becomes a magnet, it is going to attract this soft iron core here, this mechanism here. It will attract it. So, and it will close. As it attracts it, all these terminals here will close. So that makes the input and the output to close with each other, here and here, in that manner. And the water heater starts running. So how do we now do this? Because in this case, we are going to control only the coil in order to control our water heater. So in that case, we are going to pick neutral for A1. You can pick it here. Pick it from here, from the input side of your magnetic contactor. While remaining A2. The A2, we are going to pick the live. We are going to pick it from here. When we pick it from here, we bring it down and bring it here. So the live, this live is coming to feed A2, but we will not feed it directly to A2. We are now going to have our 3 switches, just like I told you. This is 1 gang 2-way switch. This one is the intermediate switch. And this is another 1 gang 2-way switch. So this is intermediate switch. Don't forget. So this is the way intermediate switch is designed. So let's see this. So these are the 3 switches. This one is intermediate switch, intermediate switch. This is 1 gang 2-way switch. And this is another 1 gang 2-way switch. So let's see how the connection is carried out. Our supply that we are bringing from here now, from the input, we tap it from the input terminal of the magnetic contactor. We are bringing it here to the common. When you see your 1 gang 2-way switch, it has 3 terminals, common, L1 and L2. So we are going to feed it to common. So from here now, we are going to run cable from this switch here to our intermediate switch. So have you seen it? So then we are going to run it again, another set of cable. We used to call them travelers. Finally, from the common of the touch switch, this is L1, L2, common here. And this is common here, L2, L1. This is a traveler. We used to call this cable traveler. So this switch might be in the first room, second room, and the third room. Or in the first room, kitchen, and the second room. Depending on those positions, number of positions where we want to control our water heater switch from. So then from the common of the third switch, we now take it directly to the A2. So with this now, this water heater tank can be controlled from any of these three positions. This could be in room 1, room 2, and room 3. So in each of these rooms, we can control it. Let's see how possible this is. From our water heater, from our distribution board, the supply passes through the contactor to the water heater, but the contactor is open when it is not energized. So, and to energize it, we need to feed the supply to the A1 and A2 of the coil of the contactor. So that's why we feed neutral directly to it, remaining live. So the live now, we pick the live supply from the terminal 1 input of the magnetic contactor. We brought it down straight to the common of the first switch. Then from this first switch, we are going to run a set of cables, a set of 2 cables to the intermediate switch in the second room. Then from the intermediate switch in the second room, we run another 2 sets of cables to the 1-gang 2-way switch in the third room. So, and the common of the switch in the third room will now come back to feed our A1. Let us now see how it works. The moment there is supply here now, and it comes here, let's see it here. So the switching position, have you seen it, is here now. So the live will go this way, have you seen it? But look at the position where the common is. The common is up here. So in this case, the water heater is off. So if I want to put it on, I have to shift the position of my switch down here. So in this case, this water heater will be working. So in this room also, by the time you open this switch, you know, this is the way it goes. By the time you press it, the connection will shift from here to here. And since the circuit is not complete, the water heater goes off. Likewise here, as it is here now, if I shift it to this point, and if I trace it, you know, no complete circuit. So the water heater will go off. So in those 3 positions, we can put it on and off, depending on what we want. So that is how to carry out the connection. But there is one precaution that must be keenly observed. What is that? The supply that is fed to control our switches must not be taken from another final subcircuit in the distribution board. It has to be taken from the same breaker that feeds the water heater. So because if you take it from another final subcircuit, another breaker, if that breaker goes off, if they put it off, this thing may not be able to control it, even when there is supply in the magnetic contactor. So we need to be very careful. The same cable that feeds the magnetic contactor from the distribution board is the one that is going to supply the control signal for the switches here. So we need to be very careful of that when we are carrying out the connection. So our magnetic contactor can be packaged, can put it in a casing, even we can put indicator. When the water heater is running, indicator will show that the water heater is on in the casing of provided for the magnetic contactor. You can have different, even we can have anything depending on your design. But this is how to wire it in a very simple term. So till I come your way next time, if you have any observation or any contribution to this wiring diagram, you can put your observations in the comment section. So if I look at it, we are also going to learn from that observation. No one monopolizes knowledge. And that is why I always say the platform is open to everyone to contribute. So I'm going to see you in my next one. I'm your one and only Engineer Oxford. I'm going to see you next time. Bye.